Okay, hello. I'd like to start the tech tour here. My name is Bert Ahn. I'm Director of Field Marketing at on Semiconductor for the automotive sensors we have. On Semiconductor is participating in this event for several years already. We are increasing our participation on an annual basis because we think it's really key to be aligned with all the ecosystem players which we see here. 10 years ago we were just at that time when we've been Optina, we've been focusing on single components. Today we talk about real multi-camera systems merged with radar and LiDAR data. We have some of our products presented here, and I'd like to take a quick tour with you to showcase what we are showing. Maybe we start over there on the right side.
No, we're going to sell the MMSE.
So what we are showing here is a megapixel global shutter solution. The purpose of this demo is to show the usage of a driver monitor camera, which is embedded here in the middle, and we have a near-infrared illumination on the right and the left side. If I move a little down, you see my face. It's detecting glasses. The status is indicated by the different windows here, and it should show how a driver monitor is working and the performance of a global shutter sensor aligned with these 940 nanometer LEDs. Here we have our first radar solution. We acquired the radar technology team of IBM in Haifa roughly 2 years ago. And this is now the first product we introduce. It's a silicon germanium 79 gigahertz radar system. The interesting part here is you can make out of this single MMIC more or less two solutions, short range and long range, because we have 4 receiving channels, but you can attach really 8 antennas, and then you can switch between 4 receivers and 4 antennas and the another 4 antennas for different purposes on the fly. So you have more or less 2 systems in one solution, and this will help the OEMs to decrease the form factor, which is very important. So you can attach more functionality in a smaller space. Okay. Here on this side, we are showing first time our Pandion LiDAR demo. It's a flash demo, which means the whole area is illuminated with an LED, and then we are scanning column by column with a SPAD array of 400 by 100 pixels, the scene. We have very nice demonstrators, so you see the distance. You can even detect faces in front of that. So who is interested is invited to come to our demo here, and my colleague Aiden from Sensor Technologies, whom we acquired in May 2018, roughly a year ago, will tell you exactly how this works. On this side we have another interesting demonstration. This is for in-cabin monitoring, and this demo really outlines our cooperation with ecosystem players. So here in this demo we have included an umbrella SoC, and what you see running here, there's detection of the surface and the shapes and the classification of the objects. This is done by a software from Iris running on the umbrella device. So this system can handle up to 6 cameras, can be even a mix of global shutter and rolling shutter cameras. What you see here now is we have 3 cameras on top. This one is looking in the wrong direction a little bit, but you see near-infrared illuminators here. Though you see a colored picture, if the light will go down, you still see a video. This is illuminated at 940 nanometers with these LEDs. The special or innovative thing here with the image sensor is that we are using an RGB IR color filter. So it's not the classical color video which you can get as well information for near infrared. And the umbrella SoC is taking care about that. A regular color video would look really bad if you do not correct the near infrared part of this video. And this is demonstrated here. We as well introduce our highest resolution automotive sensor here. You can see an 8 megapixel resolution. It's best in class dynamic range sensor up to 140 dB. It's going to be used very much in front cameras. For front cameras, you don't have such a nice color video displayed. You just get the raw video, and algorithms or software are extracting the required information. But for front cameras, you need in the future that high resolution because you're supposed to recognize the shape of an object which is 100 to 200 meters in front of the car while the car is driving really higher speed, let's say 130 to 200 kilometers. Okay, on this side we are demonstrating one sensor of our new Hayabusa sensor family. The Hayabusa sensor family consists of 4 different image sensors from 1 megapixel up to 4 megapixel. What you see here is the 2.6 megapixel sensor, and the special or new or innovative solution is the so-called super exposure. If you have a very bright scene, and this is simulated here with this picture, you have very bright areas and very dark areas. An image sensor needs to provide a very broad dynamic range, but if you have very bright spot, the exposure time is very small. That means that you could miss an LED pulse. We have invented a method by which we can apply a very long exposure, but without overexposing the image. So you see here that LEDs are not flickering, and you still have, even at the bright sides of the picture, everything showed very clear. I think I went through all demos. Any questions from the audience?